we're going to hear about our contribution that we're about to make with the digital data. Distinguished colleagues, good morning. What can I say? In any company, people approach an age when they can allow themselves to speak about global things. So this is exactly what I'm going to talk to you about. I come from a big group of authors listed on this slide. All of us are working in the Exact Instruments Institute in Moscow. Our institute specializes in the development of instruments for mostly these aerospace activities. We use these instruments both for Earth remote sensing and navigation and communication. So this is exactly that I'm going to speak about today. Perhaps you have noticed in the beginning there was a small mistake on my slide. This is the theme of our conference before 2017. The conference was called From Imagery to Map, Digital Photogrammetric Technologies. But so it happened that 2017 is a breakthrough year, and it was in 2017 when the company Rockers decided to change history in the development of photogrammetry and digital mapping by announcing the advent of the era of digital reality. That is why the theme or the title of this conference is From Imagery to Digital Reality, Earth Remote Sensing and Photogrammetry. Moving in the forward ranks of trailblazing companies, we decided to make our own contribution by suggesting for discussion a theme called Global Space Data Impact to Digital Economics, thinking that one of the main tasks for digital reality would be the establishment of comfortable and safe environment for the livelihood of people, which is predetermined by the conditions and efficiency of a country's economy. In my presentation, I would like to tell you about the solutions which in the course of many years of cooperation with the company Rockers have been implemented both in our software, and we continue to implement them in projects, and the new solutions which are developed and we think could make a worthy contribution into the establishment of digital reality and finding solutions for some of the urgent needs of our country. It is well known that in our country the application of space data and the relevant space data are done based on the following programs. I'm not going to enumerate all of them because some people mentioned them before. Deputy Head of Cartography made a presentation about them, Mr. Sergei Serebryakov. I just wanted to pinpoint here that as far as the first program is concerned, which is Spatial Data Asset or Fund Establishment Program, it says that the Federal Spatial Data Fund will be done based on the compatibility of spatial data with the information contained in other state information resources. In other words, all the data must be consistent and compatible. And secondly, the single electronic mapping platform is a systemized combination of spatial data on the territory of Russia. And then we'll suggest some additional solutions for this. Second program, I'm skipping it. Valery Zaichko reported on it quite extensively. This is the Digital Earth program, our sphere of interests, and within this program include the establishment of seamless coverage of the territory of Russia by space imagery, as well as the establishment of products and services based on the Earth remote sensing data. This is a second program. And the third program, which was referred to today, is the Digital Economy program of the Russian Federation. We believe that this program is a unification of the two previous programs. The basic priorities of this program are listed on the slide. They're quite far-reaching, and we are especially interested in the last thing, which is the information structure and information security. Within this direction, we expect to establish and build an efficient system of collection, storage, and sharing of spatial data, which would meet the needs of citizens and the state in updated information on spatial objects. So the three programs, what technical solutions are available or are being developed by us at the moment for implementation of these three major exercises. Number one, at one of the Rakurs conferences, in the joint presentation with the developers of Photomod, we spoke about the flow style processing of data acquired from the Russian satellite constellation. The technologies of big data processing is based on the hardware and software complex of Photomod conveyor with a number of workstations based on Photomod software suite that allows us to operationally doing seamless mosaics on millions of square kilometers. This technology is in place. Based on this hardware software complex, we can achieve productivity of more than 3 million square kilometers per day. The developed technology allows us to do large-scale work on the establishment and updating of basic coverage based on Earth remote sensing data with the accuracy rate close to the spatial characteristics of Earth remote sensing. And we believe that the basic seamless coverage on the territory of Russia can be applied as a single coordinate platform that all other geospatial data will be coordinating with, based on the digital economy and digital Earth programs. Within the framework of the Digital Earth program, we'll have a multi-layer raster layer where the remote sensing data with different spatial resolution will be coordinated with each other, which would allow our users to get integrated information about the spatial positioning of objects and make educated decisions. This slide shows the constellation of Russian satellites whose main tasks are performed using the data acquired by this constellation. With the making this data consistent, for that we need to ensure a high precision of positioning of this geospatial data, high accuracy of the matching of the data, which should be no worse than the spatial resolution of the data. The next slide shows an example of such matched and compatible organization of the joint use of UAV and satellite imagery for integrated and 3D visualization, and including the surrounding area based on the materials of this image acquisition. That allows us to address a whole range of tasks related to security, emergency management, as well as other tasks and assignments. The global data require a new approach for their storage and application. First, global system that allows us to, with minimum distortion, describe the whole surface, and tiles data that helps us operate with huge mass of geospatial data in multi-user mode, as well as 3D mode with the minimal requirements of computer power. The tiles data format developed by us successfully resolves such a problem, and like the broadly developed systems, it can also store information in files that do not have high requirements for the productivity of the computer. This co-developed format, along with the Rakurs company, is integrated into the photo mod and will help addressing some of the goals under the digital reality and application of the remote sensing data. Now, the developed and presented materials on the seamless coverage acquired by the Russian satellite constellations was the technology of multi-raster and multispectral visualization of data, having different spatial resolution coordinated with each other. The tile format of this global data allows us to provide the state, corporate, and private users with a highly precise remote sensing data for an integrated decision making shown on this slide, like cadastre, land use, forestry, and others. Area management include also interaction and coordination of integrated use of natural potentials and resources, and tapping the potential of industrial bases and others. One of the central tasks of the territorial planning is ensuring comfortable and safe livelihoods of people. Establishment of such geoinformational model ensures efficient decision making. Geoinformational model to support the decision making, which we believe needs to be established under the digital economy program, will ensure finding solutions for comfortable and safe livelihoods of people with the subsequent optimization of costs. Based on this, we have developed requirements for how to organize geospatial data that are constructed or are to be built under the digital economy or digital earth programs. These requirements are shown on the slide, among them high accuracy and relevance of data, interagency interoperability of the data, and others. The model of comfortable and secure livelihood is based on a model. We use monitoring and geoinformational systems that supports decision making using the materials of Earth remote sensing data and the modern digital geospatial products acquired based on them. Basic parameters are shown on this slide. They include natural conditions, fairness of inhabitants, availability of essential resources, safety that includes protection from natural disasters, emergencies. Infrastructure is in place, be it social, productive, or traffic infrastructure, regional ecological advancement of the region. One of the examples of an integrated approach to studying the area and building digital geospatial products for subsequent modeling is the work on establishment of the National Atlas of Arctics. This work is done in full accordance with the requests of the President of Russian Federation as of June 2014 and the government of Russia. Now we are completing building the National Atlas of Arctic in polygraphic version. Next we'll publish an expanded digital version. Atlas is developed for geospatial data provision for decision making in the field of the development and management of Arctic zone. The chief organization is Roscartography, and the Research Institute of Exact Instruments, Precise Instruments, is also making contribution. This slide shows digital thematic models. The data that we use for that is historical data that we collected from our funds and the modern data. We demonstrate different digital models that show different aspects of life of people living in the Arctic. Zoning of areas in terms of the favorable environment, industrial infrastructure, agriculture, forestry, deer, farming, and others. Now, integration of this similar geospatial data require new description of data that would allow us to augment the single coordinate-based description with the separate object-based identifiers with the interlinkages of geospatial descriptions. This slide shows an example of a description of a road section in a traditional mapping model and its main disadvantages. The data in these models are not linked to each other, they're described by separate fragments or sections. And you know about this, of course, which leads to the fact that we don't have a single solid description of a single spatial object. An example of description of a road section in an object-based model can be shown on the next slide. All the elements of road infrastructure are fully coordinated with each other and can be found within a single description. This approach to the description of spatial objects ensures full interoperability of the information in different information systems, and organization of information about the objects allows us to organize the proper work on these objects in a single object database and implement new approaches for the creation and update of the electronic, topographic, navigational, marine, and other maps. This approach opens up new opportunities for resolving new tasks of a new class based on the models of complicated objects such as object-oriented model of urban development or economic model of the state. That is why we have established a database of a single catalog of objects and as well as the objects based on the Earth remote sensing data. Global nature of geoinformation, its massive nature, and the spread of geospatial technologies require new forms of visualization and presentation of data. Based on the tile format, modern web programming technologies, and object-based description of spatial objects as well as of complicated configuration, we are implementing a new GIS that will ensure a new form of implementation of geodata for all levels of decision making.
It will ensure continual updating of data in information user systems. Also, it will help address complicated calculation tasks for transportation, agriculture, waterways, social infrastructure, etc. Enhancing efficiency of planning at municipality level, intensification of R&D activities, providing information to people and businesses about the status of and conditions of the environment. My presentation is over. Thank you very much for your presentation, for your attention. Are there any questions? Valery, who claimed that it will take us by 2020 at least to prepare. Yes, in the beginning you said that there is a certain program that is designed to create a geospatial data fund. Program means funding, implies funding. What kind of program are you talking about? Valery, I am a technician. Maybe I should have called that an activity. So there is no program, right? No program. I think the implementation of this federal law will be done through the digital economy program. By the way, Valery, this is a good point. In fact, there is a lot of confusion. There is Law 435, drones. So when we try to outline things, everything is kind of mishmashed. I have a kind of remark. There's a good alliance of NIATP and Cartographia. But can you please clarify? On the one hand, you show that you will reach 1 meter accuracies for referencing. On the other hand, you allude to global system of coordinates. How do you manage to go from global scale to 1 meter reference geopositioning? How does your system ensure that? Technologically, these solutions are in place and well tested. When we use just geospatial data without ground control point validation, we reach 3 meters. I guess it's not only us, but anybody else can do it. What you say is that you have the relief with such accuracies. You claim that this is global referencing. We haven't invented anything new. We simply use wisely what is available. Through technology, we managed to create good reliefs, terrains, based on space data, which allows to deliver accuracy features. CARTOGRAPHIC has a question or a comment. I'd like to reinforce the point. We have good partnership but I'd like to ask a clarifying question. We tend to gravitate toward digital models of maps, and we integrate attributes that we are used to from mapping, and every time we trip on one thing, the users say, we don't need this, we need something else. So the question is, my question, do you do any research into consumer properties of the products that we're going to offer? I mean, we can organize things, present it in different ways, but do you do consumer needs analysis? You alluded to forestry management, you alluded to other applications, but do you work on needs analysis? There is a lot of research projects which sometimes lead to mass scale batches, sometimes not. We did monitoring of energy infrastructure for the benefit of Moskovskaya Energy Company and for the forest management company using drones. We work in the regions as well, that large-scale decisions are not made at the regional level yet. But one day we will get there. We set very ambitious tasks, right? And all the programs and activity areas will drive progress. In fact, what I presented to you is a look at the future. Most importantly, this information is not scattered. This model helps establish interlinkages for all kinds of data. The model will be structured by economy, of course. This is the future from my perspective. The object-oriented GIS that you mentioned, is it available already? For certain areas, yes, but it's not for general public. Maybe someday it will become available. You mentioned drones. Is it developing inside your institute or as part of collaboration? I collaborate with Rakurs very energetically on the drone. Yeah, but what about imaging? We have partners for that too. We have partners that we work with, and I haven't seen any problems thus far. So no further questions. Let's thank Oleg.